Hi everyone, and welcome to my class. I also welcome you to the lesson. This lesson is on like terms, like algebraic terms. Before I get into the lesson, I want to remind you about safety. Safety first. Whatever you do, think about safety. You are riding your bike, walking on a footpath, crossing the road, in your class, you are driving, whatever it is, think about safety. Your safety is first because it is said that a safe student is a good student. And I believe you want to be a good student. So be safe. Okay, let's get into the lesson. Like terms, let's see what the notes say. They will come back and give some little further explanation. Like terms. Like terms can be characterized as number one, terms which contain only constant numbers that can be added or subtracted to get a single integer or constant number value. Example: 3, -7, 11, 17.8, 9 are like terms. What makes them like? What makes them like terms? Number one, they are all constant numbers. Number two, they are all rational numbers. Number three, they can be added or subtracted. So that makes them like terms. Next is 3 root 2, 5 root 2, and 7 root 2 are like terms. Why? Because root 2, which is an irrational number, is common in the three terms. As you have root 2 here, irrational number, root 2 here, irrational number, and root 2 irrational number is common in the three. And these other constant or rational numbers as well are all of it. So all of them are rational numbers. Sorry, this one is a rational number and this is an irrational number. Sorry, but this irrational number is common in the three terms. So that's why the three terms are like terms. They can be added, they can be subtracted. 2. Like terms are terms which contain variables. Variables are numbers, otherwise known as alphanumeric. Symbols. Symbols are numbers, stroke alphabets, which can also be added or subtracted to get a single term value. We're still talking about like terms. Examples: x, 7x, -3x are like terms. They all have same type of variable to the same degree of exponent. X to the power 1, x to the power 1, and they are all like terms. They can be added or subtracted. Next is theta, which is a symbol for angles. 2 theta, 7 theta are all like terms because they have this theta common in all the three terms. Then here, x theta, 2x theta, and 5x theta are like terms because they have x theta in common, in common with the three terms. 3. Like terms are terms which contain same type of variables with same degree of exponents. Example: x squared, 3x squared, 8x squared are all like terms. B squared, negative 5b squared, 13b squared are all like terms because the variables are of the same degree of exponents. They can be added, the terms can be added, subtracted, just like all like terms. Now, there are a lot of things we can do with the idea of like terms and maybe unlike terms as well in mathematics, because the idea is to bring terms that have the same properties, the same characteristics together. I just give you a simple example. You go to a farm to pick apples and oranges, and you put them in one basket for convenience and bring them to the shop where you want to sell them. Number one, you have to separate them, okay, and you have to bring the apples together, and put the apples together and put the oranges together. Now, within that apple, you can have the one that are big, the one that are small or medium size, but apple is apple, so you put them together as apples. Same thing with oranges. So when you do that, they will be able to know the number of apples you have and the number of oranges you have. They will be able to maybe separate them, the good ones, the bad ones, and the rest of them. So that's why like terms, you have to bring them together, and the unlike terms, you have to ignore them or use them for whatever reason. So in the case of apple, you have the big size and the small size. That's why in terms of algebra, you can have x, which is just x. You can have 5x, which is 5 times the size of x. In other words, the big apple and the small apple. But they're apples. So that is one thing you have to understand. So let's take a simple example. Very simple. There are too many things to be done with like terms. It says here, given ax plus 3x minus 5 in bracket plus 7x minus 4x plus 3, the two algebraic expressions, you're required to add them. The first thing we do is to simplify, remove the brackets. When we remove the brackets, what we have is ax plus 3x minus 5. When we remove the other brackets, we also have 7x minus 4x plus 3. Now you have one full expression. What do? We rearrange them to get the like terms together and the unlike terms. So what are the like terms here? Ax and 4ax are like them. So we write them ax minus 4ax. Okay, that's taken care of. The next like terms are 3x and 7x, all right, plus 3x plus 7x. And the other like terms are the constants, the numbers, which is minus 5 plus 3. Then we simplify, we add up. Ax minus 4ax will be equal to negative 3ax. 3x plus 7 will be 10x. And negative 5 plus 3 will be negative 2. So this is what we have as our simplified expression from this given expression. Negative 3ax plus 10x minus 2. Can we do anything further with that? No, because we can't simplify it any further. So that becomes the answer. Now, this can apply to equations and rest of them. So in the next example, we'll talk about, I will say, the goals, the objective, the purpose of like terms, bringing them together and solving problems or whatever.